Hello everyone, we are Rushda Abbasi and Ramla Kamran, and today we will be presenting our project named Port Inspector. This project was developed for a programming fundamentals course under the guidance of Sir Abdullah at NED University. Our project demonstrates how basic network communication works using socket programming in C language. We will be explaining what a port scanner is, how it functions, the tools we used, and finally, how our code works step by step. So let's start with the introduction. A port inspector or port scanner is a tool that checks which ports on a target computer are open, closed, or filtered. It is mainly used by network administrators and security professionals to test network safety and to identify what services or applications are running on a host machine. For example, if port 80 is open, it usually means an HTTP web server might be running there. If port 22 is open, SSH access may be enabled. So, our project aims to simulate this process in a simple form using C language to understand how socket communication actually works. The main goals of our project are to develop a simple port scanner using the C programming language to understand the basics of socket programming and network communication, to analyze which ports on a given host are open or closed. Through this, we got hands on experience with network protocols, IP addressing, and how computers actually communicate over the internet using ports. Now let's move on to the working principle of our port scanner. Our program works by attempting to establish a TCP connection to a given IP address and port number. Here is how it works step by step. First, we set up a TCP socket using the socket function. Then the target IP address and port are set using a structure called sockaddr-in. The program uses the connect function to try and connect to that port. If the connection succeeds, the port is open. If it fails or times out, the port is closed or filtered. So basically, by checking the return value of the connect function, whether it's 0 or -1, we can tell the status of a port. If connects return 0, it means the TCP three-way handshake was successful, meaning there is a service listening on that port. If it returns -1, the port is either closed or blocked by a firewall.
Now let's talk about the tools and technologies we used. Our programming language is C because it gives us low-level control over network operations. We used these libraries in our code: studio.h for input and output, string.h for string handling, arpa.h for internet function, and unistd.h for closing socket. We wrote and tested our program in VS Code running on Linux since it provides built-in socket libraries and command line interface for testing. Now, let's break down the algorithm behind our scanner. The program starts entering input, the target IP, and the port range or specific port number. It loops through each port in that range. For every port, it tries to establish a TCP connection. If the connection is successful, it prints that the port is open, but if not, it marks it as closed. After scanning all ports, it displays the results and ends the program. So it's a simple yet efficient algorithm that uses binary logic, success or failure, to identify port states. Now let's go over the main parts of RC code. The first part of the code includes the necessary header files, studio.h, string.h, arpa, inet.h, and uni.std.h. These give access to input-output, network functions, and socket handling. Then we declare variables for the IP address, the port number, and the socket descriptor. Next comes the socket creation steps. Views. View socket if inet socket string is 0. Here if inet means IP for addressing and socket string means we are using TCP protocol. After that, we use a structure sock adder -in to store the target IP and port information. We convert the IP from string format to binary using inet adder and a port to network order using edge tones. Then comes the most important line, the connect function. It tries to connect to the target address. If it returns 0, we print. If it returns 0, we print port is open. If it returns -1, we print port is closed. Finally, we call close to release system resources and move to the next port if we are scanning a range. In summary, it's a client-side program that uses the success or failure of a connect call to determine the port's status. Now, Roshita will let you see the code executes.
Okay, so we are here on Linux Visual Studio, so we can run the code. This is the code. You can have a look. First, we will open a port on the terminal of the Linux by typing this command that I am showing you right now. We will add the ampersand symbol at the end to let this command run in the background. Now, for example, we are opening the port 1337. Let's check it if our program is doing its work or not. It is asking for the IP address now. Let's enter it. Now the port that we just opened, let's enter that. And it is showing that this port is opened. Now let's check for another port that might be closed. Let's say we enter the port 8000 and the program shows that this port is closed. So that is how this code works. Here is it, you can see it, and we can see that it is showing the correct output. Hope you understand it.
That's it. This is our program. Thank you very much.